Hello everyone, welcome back to Little Slaw YouTube channel, and today we're going to tackle one of the most commonly asked interview questions in performance testing, and that's the pacing calculation. Again, this is a very tricky question that many candidates get wrong, so please pay close attention to it. And here's the question. So how will you calculate the pacing to achieve 15,000 transactions per second with 1,000 users when one iteration takes 150 seconds including the think time, right? So let me write down it for you. So what we are given, so the number of users is 1,000. The target transactions per second is 15,000. So per second it should be 15,000, and one iteration takes 150 seconds including think time, and then we need to find the pacing for this, right? So now before we jump into calculations, let me tell you this question has a catch, and let's go step by step. So before we calculate pacing, we need to understand what we are actually trying to achieve here. So we have 1,000 visual users who are executing the transactions in our performance testing, right? And we want to achieve a throughput of 15,000 transactions per second. Okay, not per hour, per minute or per hour, it's per second. And each iteration meaning one complete execution of a script, which currently takes 150 seconds. And now we need to add the pacing to control the transaction rate and meet our target transactions per second. So it sounds very straightforward, right? So like, wait, we'll see what happens in the next slide. So the key concept is Little's Law. So now, as the name of this channel suggests, yeah, we always go back to Little's Law for understanding these concepts. And Little's Law states n equals lambda times r, where n is the number of users in the system and lambda stands for the throughput or TPS, and then r is the response time in seconds. So this law helps us understand the relationship between concurrency, throughput, and response time. And for our scenario, we need to find the total time including the pacing. So let's apply the formula. And the first step in it here is to calculate the total time required. So let's use the Little's law to find the response time. So if we rearrange the formula, so previously we had the formula as n equals lambda times r. So when we are rearranging it, we get r equals n divided by lambda, right? So let's substitute our values. So r equals 1,000 users, which is divided by 15,000 transactions per second, whereas we get a response time of r, which is equal to 0.0667 seconds. Now wait a minute, this tells us each iteration should complete in 0.0667 seconds, right? But we already know that each iteration takes 150 seconds, so something doesn't add up here, right? So can you relate that, right? So let me show you the correct approach. So going to the next. So the reason why I have taken you with this is, I don't know, because many of us do this common mistake. If we rearrange the throughput and the users, then we'll be able to find the response time, but that is not how it actually works. So here comes the correct approach. So what I do here is, I'm thinking a little bit different way. I mean, the original way, the actual way. So we need to think in terms of iterations per second, right? So the formula is iterations per second equals transactions per second divided by transactions per iteration. So right. And now I'm making an assumption here that we have one transaction per iteration. And this is a very common scenario. So the required iterations per second equals 15,000, right? And now with 1,000 users, each user must complete 15,000 divided by 1,000, which is 15 iterations per second. This means the time per iteration should be 1 divided by 15, which is 0.0667 seconds. So now I think you must be seeing what the actual problem is, right? So now what I'm going to do is I'm going to try the second step where I'm going to calculate the required pacing, right? So here I'm doing the total iteration, which is equal to execution time plus pacing. So I'm rearranging the pacing equals total iteration minus the execution time. So the total time needed for each iteration is 0.0667 seconds. The current execution time is 150 seconds. Therefore, the pacing equals 0.0667 minus 150, which is minus 149.933, and it shows negative pacing, right? And we all know this is impossible because you cannot have negative pacing. So this result is telling us something very important, that is the target is impossible to achieve with the given parameters. And let's try to understand the result. So why is this impossible? And let me break it down for you. Each user takes 150 seconds per iteration with 1000 users maximum, and the TPS like with 1000 users maximum, the TPS we can achieve is 1000 divided by 150, which is equals to 6.67 TPS. But we are being asked to achieve 15,000 TPS, so that's 2250 times more than what's physically possible with these parameters. And the conclusion is very clear: the requirements are contradictory and cannot be met. So this is a tricky question which is designed to test whether we understand the fundamentals or we will just blindly apply the formulas. So the next step that I'm going to do is correct pacing formula. So now let me show you the correct formula for calculating the pacing when the scenario is achievable. So the formula is pacing equals user divided by target TPS minus iteration time. So let's try with a more realistic target, which means which is like 100 TPS. So the pacing equals 1000 divided by 100 minus 150. So the pacing is equals 10 minus 150, and hence the pacing is minus 140. So still it is impossible because even with 100 TPS we can't achieve because our iteration time is too long. So the key takeaway here is always check the feasibility before calculating the pacing. And that's why I have this feasibility check formula. And this is the most important formula because you need to remember that this should be your first step before calculating the pacing, because here you can calculate the maximum TPS which equals to the users divided by iteration time. So for our scenario, I've got the maximum TPS which is 1000 divided by 150, right? And the maximum TPS is 6.67, which is 6.67 transactions per second. So this is the ceiling, which is the maximum that we can achieve. And now here is the rule: if your target TPS is greater than maximum TPS, the test is not feasible. So what we do is, to make it feasible, we need to either increase the number of users dramatically or reduce the iteration time by optimizing our script, or we have to adjust the target TPS to realistic values. So this feasibility check will actually save us hours of troubleshooting in real projects. And let me give you a realistic scenario. For example, let me show you a realistic scenario where the pacing actually works. So let's change a parameter to something achievable. So the user here is 1000. The target TPS is 5 transactions per second. So you can notice that this is less than our maximum of 6.67, and the iteration time is 150 seconds, which is for each iteration it takes 150 seconds, right? First, let's verify the feasibility. So the maximum TPS, that is 1000 divided by 150, which is equal to 6.67, which is achievable. And the next thing is pacing, right? So target is 5 TPS, which is less than 6.67. I mean, the check mark is achievable. And then the calculation of pacing. So pacing equals 1000 divided by 5 minus 150. So the pacing is 200 minus 150, where we get 50 seconds, right? So the pacing equals 50 seconds, which is very perfect because we need to add 50 seconds of pacing between iterations to achieve 5 TPS with 1000 users. So the interview answer summary here is, let me quickly go back to the original question. So how you should answer this in an interview. So the question was, calculate the pacing to achieve 15,000 TPS with 1000 users and 150-second iterations, right? So your answer should be, the pacing cannot be calculated because the target is impossible to achieve. But don't stop there. Here is, you should elaborate. So with 1000 users and 150-second iterations, the maximum achievable TPS is approximately 6.67 TPS. And to achieve 15,000 TPS, we would approximately need 2.25 million users, and we would need to reduce the iteration time to 0.0667 seconds, which is completely unrealistic. So I would recommend reviewing the performance requirements with the stakeholders and adjusting either the user count, the target TPS are optimizing the script to significantly reduce the iteration time. So this answer will show you that you have understood the fundamentals and you can identify the impossible scenarios, and you know how to have the conversations with stakeholders about any realistic goals. And this is what separates junior testers from experienced performance engineers. And moving on to the last slide, the key formula references. So before we wrap up, let me give you a quick reference of all the key formulas that we need to remember. So formula number one, which is the pacing formula, that is pacing equals user divided by TPS minus iteration. The formula number two, which is maximum TPS equals users divided by iteration time, which is which you always calculate the first. The formula third, which is required users equals TPS multiplied by iteration time plus pacing. And finally, we have got the Little's law, the concurrency equals transactions per second multiplied by response time. And here is my golden tip for you. Always validate the feasibility before calculating pacing, and this will save you from embarrassing mistakes in interviews and in real projects. So with that, I come to the end of this video. Until I see you all in another interesting video, it's bye bye from Vasan Shanmugam and your favorite Little's Law YouTube channel. Take care and bye bye.